Okay, so this is our last lesson for Unit 1, kind of like a little bonus lesson looking at these compound inequalities. So we talked about the and the or and what those mean. We talked about how or just means you put them all together. We talked about how and means the overlap between the two sets. So we want to really think about what that actually means when we say put it all on one graph, or when we say the overlap between the two sets. And these are going to provide us with some kind of unique scenarios. So example. If you see a sign that says guess under 3 and over 62 get free admission, the question here is, does this make sense? Why or why not? So when we use the word and means overlap, and means you have to fall into both sets. So when they say, does this make sense? I would say, no, it does not make sense. The reason is you can't be under 3 and over 62. There's no overlap there. Those things can't happen at the same time. So to change it, it should say or. And if it says or, that's like one or the other, and plenty of people fall into one or the other. You just can't possibly fall into both. All right, so we're gonna look this first set. They're kind of given to us already. So I'm gonna breeze through these just so you can see exactly what the ands end up meaning, exactly what the ors end up meaning. So these top 4 have an and. What the and means is you need an overlap between those two sets. All right, so I'm gonna kind of sketch this out in pencil first. So we're gonna wait on our final answer until I'm ready to like go over it in pen, right? So less than -3 means -3 and then off to the left. Greater than 7 means 7 and then off to the right. Okay, now when we say and, that means overlap. Now this scenario is just like this scenario. There is no overlap between those two sets. So when we are looking for an overlap, we are not going to find any. So the interval notation, there is no solution because there is no overlap between those two sets. All right, let's look at this one. Greater than or equal to 0. And less than 6. Okay, so here this one goes up, this one goes down. There is this overlap in the middle. Okay, so I'm gonna ignore these extra arrows and we're just looking at the overlap in the middle. So let me go over this. So greater than or equal to 0 or less than 6. So this one's kind of the normal and graph that we've been looking at the last couple lessons. So our interval notation starts at 0, ends at 6. Okay, 2 other cases. Both of them less than, both of them greater than. You'll see how that shakes out when we look at an and. So less than or equal to 5 and less than or equal to 8. Like this. Okay, so we want the overlap. The overlap is where I have double lines. That's here. Okay, I have overlap right here, which means when I want my final answer, I don't want to include this because that's only in one of the sets, not both of the sets. So the and ends up being this. Okay, so the and interval notation starts with a left arrow, ends with 5. Which is included. So if I want to be less than this number and less than this number, I have to be less than the smaller one. Because if it's like 6, 7, or 8, sure, it's in this set, but it's not in this set, and it's supposed to be in both. All right, my last and scenario, we have a double greater than, so let's see how that plays out. So greater than -4 and greater than or equal to 2. Again, I need overlap. Overlap is where I have the double line, which is happening right here. So I'm getting rid of everything that's not an overlap because it's supposed to be an and specifically. So final answer is this. So when I say and, bigger than this one and bigger than this one has to be bigger than the bigger one because anything in between wouldn't be bigger than both of these numbers. So interval notation starts at 2 and goes off forever to the right. So those are the special cases with the and, all right? We have like 4 different things that could happen here. Now let's look at the ors. Ors means we just put them all on the same number line and see what happens. Not an overlap, just everything all together. So here, again, I'm gonna start it in pencil. Less than -8 means this. Greater than 1 means this. Now, it's an OR, so I just put them all together. So no matter where they fall, they're going to be part of our OR graph. So that just means I do this, kind of like a normal looking OR graph. So let's write down the interval notation. So from the left up until -8, not included. Then a little union symbol to bring these two sets together. Next set starts at 1 and goes off to the right. So that one's just kind of a normal OR graph. Let's see how this one plays out. We have both greater thans here. So we just put them on the same number line. Everything counts. So greater than or equal to a -2 or greater than 7. Okay, so we want everything, and everything would be all of this right here. Because if something's greater than 7, it's automatically greater than -2. So I really just have to worry about that part. So this is all of it. Starts here and goes all the way off to the right. So I don't really have to worry about specifying that part right there. So interval notation starts on the left with a -2 included and goes off to the right. Okay, 2 more OR situations here. This first one, less than or equal to 3, or less than or equal to -9. So here's the -9. Let me go down here. So OR means everything. We put it all together on the same graph. That includes all of this. So if something is less than -9, it's automatically less than 3, because -9 is less than 3. So again, we really just have to worry about that set. So putting it all on the same graph and just seeing what comes out of it just ends up being this set right here. So I don't have to really specify that, just like number 6. So interval notation, the left end is an arrow, and it goes up until we hit 3, which is included. Last one of these, opposite, 1 greater than, 1 less than. Let's see how this one plays out. Greater than -1 is this. Less than +1 is this. So see how these ones kind of like cross over each other and go off in opposite directions? With an AND graph, we would only want this part, but an OR graph, we'll take it all. We'll take everything. So everything ends up getting covered. So we saw something like this a few topics ago. We get everything, the entire number line, because everything is either in this set or this set. Every single number would work. So we cover everything. Interval notation goes from arrow to arrow, -infinity to +infinity. We could also say all real numbers for that set. Okay, so in these first 8, we saw literally every possible scenario that could happen. So let's just play around with a handful of these examples. All right, so I'm actually gonna have you guys take a look at the next page, number 11. So number 11, we have an AND graph, so we're gonna solve it. And remember, AND means we are looking for the overlap between those two sets. Overlap only. So this first one, solve for R. I'm gonna subtract this 7. So 10 minus 7 is 3. I'm not gonna put anything on the number line until I solve everything. To solve this one, start by adding 1. So -3 plus 1 is a -2. And then divide this -2. So since I'm dividing by a negative, I am flipping this sign. And -2 divided by a -2 is 1. So I need to put them on the same number line. All right, so this less than 3 means I start at 3 and go off to the left. Less than or equal to 1 means I start at 1 and go off to the left. Okay, so I need to be very careful to pay attention to this. And means the overlap. So that just means I have to have a double arrow. So I have a double arrow all the way right here, just not 1 to 3. Because anything 1 to 3 is less than 3, but it's not less than 1. And it has to fall into these categories. So I'm not using this portion since I need the overlap. So it is just this portion here. When I want the overlap between smaller than 3 and smaller than 1, it would just be smaller than 1. So interval notation, we go from a left arrow to a +1, which is included. So that was one special case of an AND. Next one I want us to look at is number 14 over here. So this one's an OR. So this first one, start by subtracting this 1 from both sides. So subtract 1 from -17. And then second step would be to divide by that -2. So I flip my symbol. This would be a 9. So that's one part. So this is an or you can just feel free to put it all in one number line. So less than or equal to 9 would be this. Then this one, start by adding 5 to both sides. So negative 50 plus 5 would be this. And then divide both sides by 5. So negative 45 divided by 5. So I get less than or equal to a negative 9. So the negative 9 is down here, and that goes off to the left. So or means the overlap. Anything that's shaded counts. So when I say less than 9 and less than negative 9, I might as well just say this, because anything in this set is immediately in this set. So I'm really just taking this and going all the way to the left. So I don't really have to worry about this portion of it. So interval notation, my left arrow would be a negative infinity, and it goes up to the 9, and I close that with a bracket. All right, so that's 14. We're gonna look at the very next one, number 15. This is another or. We'll see how this one plays out. So solve both of these. I'm gonna start by subtracting 6 from both sides. So negative 4 minus 6, and then divide by this 2. So negative 10 divided by 2. And again, this is an or, so feel free to just put it all in one number line. So negative 5 greater than goes off to the right, and then solve this one. So subtract 5 from both sides. So on this right, 41 minus 5 is 36, and divide both sides by that 9. So less than or equal to 36 divided by 9 is 4. So all on one number line. Less than or equal to 4, this is going to be a closed circle right here, and less than or equal to takes me off to the left. So this is an or, which means you just put it all on one number line, and what ends up happening here is the whole entire number line ends up getting covered by one of these two sets. So final answer ends up being everything. I don't really need to have these like specific values in the middle, because every number ever is either bigger than negative 5 or smaller than 4. So we get the whole number line, and when we have the whole number line, we just write these double infinities for our interval notation. So that's one other special or graph. We're gonna finish off with number 18, which is another special and graph. So one last set to solve. This one on the left, I need to add this 4 to both sides. So negative 16 plus 4 is a negative 12. Divide both sides by 6. So since what I'm dividing by is a positive, I don't flip. So negative 12 divided by 6 is negative 2. Don't plot anything yet because this is an and, so I need to wait to see what the overlap is. This one, I'm just going to subtract 2 from both sides. So negative 5 minus 2 is negative 7. So this is an and. I'm looking for an overlap, so I'm going to sketch it in pencil just to see what happens. So greater than or equal to a negative 2. Here's the negative 2, and I go off to the right. Less than or equal to a negative 7. Here's the negative 7, and I go off to the left. So this is an and. And means overlap. And means I need 2 arrows going over the same space at the same time. That's never going to happen here. This one goes off to the left. This one goes off to the right. They never go in the same direction and overlap each other. So if what I'm looking for is an overlap, I'm not going to find any. Okay, so this, when I'm looking at it as an and, has no solution. So nothing on the number line gets shaded. The interval notation, we just use that no solution symbol. Okay, so that is the end of our little bonus lesson.